Thank you. So in this question, we want to compute the slope of tangent line using the definition and the differentiation rule. Using the differentiation rule is not difficult. And the f prime, in general case, it would be 2x. So we want to compute the slope at this point. It means that we need to evaluate the first derivative at this point, which is 2 here, which is 1 and give us 2. So we can use the definition. This is the derivative at any point a, right? So it will be the limit when x approaches a, f of x minus fa divided by x minus 8. F of x is given, which is x squared plus 1. F of a, it means we will replace x by a. It is a squared minus 1. The denominator is x minus a. Right? Very good. The limit when x approaches a here. Now, 1 cancel 1 here, right? So the numerator becomes x squared minus a squared. The denominator is x minus a. So, can we simplify this fraction?
Difference of squares.
Perfect. That is x minus a times x plus a, right? This is a product, remember? X minus a, you can imagine this is x minus a times 1. Therefore, we can simplify it, and this becomes the limit when here, right, simplified, it becomes limit of x plus a when x approaches a. There's something wrong here. Do I use? Oh yeah, that's fine. Nothing wrong. Okay. Then x approaches a, it gives us, what do we have here?
2a.
Very good. 2a. So f prime at a would be 2a. This makes sense here, right? The f prime at any point x is 2x, just a different notation. Therefore, we found a similar result. F prime at 1 will be 2 times 1, which is 2. So these two things are the same. Very good. So if in the test you see they're not the same, they might have some mistake in your calculation. Okay. C, linearization or tangent line. The tangent line approximate the function g of x at the point A is given by this formula. G of x is approximate by Lx, where it is g of a plus g prime of at a times x minus a. Here, g is a given function, a is a given number. So g of a would be a number, right? G prime is also a number. A is a number. Therefore, this linear approximation, what is the highest degree of this polynomial?
1.
Very good. That is why we call it linear. Linear means the degree is 1. So that is why we call it linearization of the function. Now, so we are given that a is 1, right? So our job is to find g prime and g at a, right? This is the, okay, Now, in our case, we are given the function f, right? It means that we need to find f prime at 1 and f at 1. Okay? These are two things we need to know. I changed the notation to g to avoid confusion. G, or it is a name of a function. So now, let us do it. What is f at 1?
Two.
Very good, which is 1 squared plus 1, which is 2. So from the previous part, we know that f prime at 1 is 2, right? We know these two information. Therefore, f of x is approximate by the function, we call it L of x. L of x in this case, it would be f at this point plus f prime at this point multiplied x minus the point here. We know everything, right? So what do we have here?
Two.
This is 2, okay, plus
That's 2 times
2 times
1.
x minus 1, very good. And therefore, f of x, we can approximate it, and it will be 2x plus, yeah, just 2x, right? 2 cancel with 2. Near the point x is equal to 1. This linear approximation is only good near the point here. Okay? Now, the second part. We need to find f of 0.95. And it would be 0.95 squared plus 1. What is it? What do we have here? Can you use a calculator and find this one? This is f at 0.95. We need to find L of 0.95, right? What do we have here? Let us write it this way. This is the linear approximation, right? So what is it?
2 times 0.95.
Very good. Which is 1.9, right? Yeah, correct. So the real value is 1.9, 0.25 here is larger, right? So the linear approximation here is underestimate. Okay, that's it.